The next two examples are also nonlinear systems, but we will be able to use elimination rather than substitution. So looking at the first question, again, not a bad idea to have some sort of concept as to what the graph would look like if we were to graph it. This first one, if it were 1x squared and 1y squared would be a circle, dealing with that plus in between. Instead of a circle, this is actually an ellipse. And again, we'll talk about how to graph those later. This other one, notice it's similar to the first, but there's a subtraction sign in between, and the subtraction sign turns it into a hyperbola, which we can, again, graph later. But the point here is that we're probably going to we could end up with up to 4 points of intersection, which is more than what we're used to. So again, this is by elimination, which means I have everything in the same form. I'm going to take this second equation and just multiply everything by -1. And the reason I did that is now I have a 1x squared and a -1x squared, which cancel, which gives me 9y squared equals 9, y squared equals 1, so y equals plus or minus 1. So there's no restrictions on the domain here at all. We can use any values, and no restrictions on the range either. So I'm using plus and minus 1. Now, solving by elimination, again, I'm going to take that 1, I'm going to plug it into either of the equations. So x squared plus 5 times 1 squared equals 25. 5 times 1 squared is obviously 1. So I get x squared plus 5 equals 25. X squared equals 20. If I take the square root of each side, I end up with, breaking this down, plus or minus 2 radical 5. So what that tells me is I have a solution at 2 radical 5 comma 1 and at -2 radical 5 comma 1. Now if I plug in the -1, because I had two y values, if I plug in the -1, -1 squared would still be +1, and I'm going to end up with these two same values again. If you don't believe me, feel free to plug it in. But if I plug in -1, these are also solutions. So now I've got 2 radical 5 comma -1 and -2 radical 5 comma -1. So those are my 4 solutions. Again, not a bad idea to go ahead and go into Desmos and graph those two and see that those are in fact the points of intersection. Here's a question for you to try on your own. So try the question, then press play to check your work. So again, the first thing I'm going to do is think about what would these look like if I graphed them. The first one is very clearly a circle. We have just a coefficient of 1 in front of each. The second, again, because there's a plus in between, but the coefficient is not 1, this is an ellipse. So it's possible that I'm going to have 4 solutions yet again. It's also possible that the ellipse would maybe be all the way on the outside, which means no solution, or that it would just intersect in 2 spots. So let's see what happens. If I take this first equation, I'm going to take everything times -4. That gives me -4x squared, -4y squared equals -64. And when I add these things together, I get +5y squared equals -28. Now, the fact that it's a fraction doesn't really bother me. It just means a little bit harder work. But the fact that even if I divide by 5, y squared is equal to a negative value, that tells me that there's a problem. So if y squared is a negative value, there's no number that I can square and it be negative, since a negative times a negative is a positive and a positive times a positive is a positive. Because there is no y value that would work, this is going to be one of those no solution questions, which means if I did graph it, it's going to obviously be an ellipse, either completely contained within the circle, or more likely, because of the larger values, one that actually contains the circle. So no solution or inconsistent.